Hi everyone. We are going to start with property-based problems. The property that which I am going to use over here is integration of e raised to x f of x plus f dash x dx. The answer for this is e raised to x f of x plus c. Okay. Take a brief look at the property e raised to x within the bracket f of x plus f dash x. The answer should be e raised to e raised to x f of x plus c. So the main idea is the function of x and its derivative will be there within the box bracket, and outside the box bracket there will be e raised to x. Fine. Yeah. So let's take some examples. Integration e raised to x cot x plus log sin x dx. Cot x plus log sin x dx. Right. Now see, we know the derivative of cot x is minus cos x square x. Derivative of cot x is minus cos x square x, which is not there over here. Okay. So I'll just try and reverse this. I'll just reverse this. Log sin x plus cot x dx. I just reversed. Okay. Now I'll try to find out what is the derivative of log sin x. Can you just do some kind of rough work and check whether the derivative of log sin x is cot x?
Yes, sir, it is cortex.
So my question to you was, what is the derivative of log sin x? The derivative of log sin x, if you just check, if f of x is equal to log sin x, the derivative of log sin x will be 1 upon sin x into dy dx of sin x, the derivative part. Okay, so it is cos x upon sin x, which is equal to cot x, right? So as you see, the function and its derivative are present in the box bracket f of x, and this is f dash x, f of x and f dash x, and they are separated with a plus sign, and there is e raised to x outside. So can we just apply the property e raised to x f of x plus c? As per the property, can we write e raised to x f of x plus c? Yes or no? Correct. So this was our question, e raised to x f of x plus f dash x, right? And we are showing it to the paper character. F of x is log sin x, f dash x is cot x. So the answer for this will be e raised to x f of x plus c, e raised to x log sin x. Okay, f of x is log sin x, e raised to x log sin x plus c. Fine. Let's take another example. I is equal to e raised to x tan x plus log sec x, e raised to x tan x plus log sec x. Now sec x derivative is tan x derivative is sec square x. So what is the first step? Can you just reply over the chat over here, over the chat box? Yes, correct. We have to reverse this. Log sec x plus tan x. Now try and find out the derivative of log sec x. Come on, can you do it on your own? Try and find out the derivative of log sec x. Is it tan x? Log sec x is 1 upon sec x into dy dx of sec x. So are we getting tan x as the derivative of log sec x? Yes or no? If you are getting an answer, just put yes over the chat box. Okay, so this is first part is f of x, and the second part is f dash x. Fine. So the answer will be e raised to x, f of x plus c. What is f of x? F of x is equal to log sec x plus c. Fine. Okay. Next example. So we are taking another example over here. Integration of e raised to x sec x plus log sec x plus tan x. Okay. So what I'll do is I'll reverse this. Log sec x plus tan x plus sec x. Now the first part is f of x. F of x is equal to log sec x plus tan x. F dash x. So this will be 1 upon sec x plus tan x into dy dx of sec x plus tan x into dy dx of sec x plus tan x. Fine. So the derivative of sec x is sec x tan x plus the derivative of tan x is sec square x. So let's take sec x common in the numerator. So it will be tan x plus sec x within the bracket upon sec x plus tan x upon sec x plus tan x. Fine. So this and this is getting cancelled. The answer is sec x. So see, we got sec x, and the derivative of log sec x plus tan x is nothing but sec x. So the first term becomes f of x, and the second term becomes f dash x. So e raised to x f of x plus f dash x, right? So e raised to x f of x plus f dash x is equal to e raised to x f of x plus c. What is f of x? Log sec x plus tan x plus c. Fine. Okay, so let's proceed with this now by taking another example. E raised to x 2 minus sine to x 1 minus cos to x. E raised to x 2 minus sine to x upon 1 minus cos to x. We'll use the half angle formula for 1 minus cos to x and sine to x. The half angle for 1 minus sine to x is 2 sine x is the half angle formula for sine to x is 2 sine x cos x. And the half angle for 1 minus cos 2x is 2 sine square x. 2 sine square x. So e raised to x. Now split 2 upon 2 sine square x and minus 2 sine x upon sine x cos x upon 2 sine square x. I've split this upon this minus 2 sine x cos x upon 2 sine square x. Now when we split, what happens is 2 and 2 gets cancelled, and here also 2 and 2 gets cancelled. Okay, sine x and sine square x, one sine is getting cancelled. What about the first term? What should I write the first term as? Can anyone tell me? 1 upon sine square x. 1 upon sine square x can be written as cosec square x, the reciprocal of sine. Okay, cosec square x. 1 upon sine square x can be written as cosec square x. There is minus sign in between, so I'm putting a minus sign. Fine. Cos x upon sine x is cot x dx. Fine. We'll just reverse this. Minus cot x plus cosec square x dx. See, we know the derivative of cot is minus cosec square. Okay, so f of x, this side is I. F of x, if it is minus cot x, f dash x is minus of minus cosec square x. We'll keep this minus sign outside, and the answer is plus cosec square x. So if you carefully take a look at this, the first term is f of x and the second term is f dash x. Second term is f dash x. Okay, so the final answer over here will be e raised to x f of x plus c, as per the property which is being taught to you currently. So this is equal to e raised to x f of x plus c. What is your f of x? F of x is equal to minus cot x plus c. Fine. We'll take one more example after this. Fine. Integration e raised to x 1 minus sin x 1 minus cos x dx. Again, we'll put half angle formula for 1 minus cos x and half angle for sin x. So this will be 1 minus 2 sin x by 2 cos x by 2 upon 1 minus cos 2 sin square x by 2 2 sin square x by 2. Okay. So e raised to x 1 upon 2 sin square x by 2 minus 2 sin x by 2 cos x by 2 upon 2 sin square x by 2. After taking the half angle formula, what I've done is split. Okay. So here 2 and 2 will get cancelled. Sin x by 2 and 1 sin will get cancelled. Send this sin square up. So it will be e raised to x cos x square x by 2 upon 2. This 2, which I'm highlighting, will remain in the denominator. Okay. So I'll show you the slide once again. See, sin square will go up. It will become cos x square x by 2 upon 2 minus cos x by 2 upon sin x by 2. That is equal to cot x by 2. Cot x by 2. E raised to x minus cot x by 2 plus cos x square x by 2 upon 2 cos x square x by 2 upon 2. Now try and calculate the derivative of minus cot x by 2. If this is f of x, okay, the derivative of minus cot x by 2 is minus into minus cos x square x by 2 into d by dx of, will you tell me what is d by dx of? What is the part of the round bracket? Can you tell me? I'm calculating the derivative of minus cot x by 2. This minus is outside. Derivative of minus cot is minus cos x square x by 2. So what is the part of the round bracket? Come on, tell me. Yes, I'm waiting for your response. Correct. X by 2. Chain rule. Okay. So this is equal to cos x square x by 2. Okay. Into derivative of x by 2 is half. Derivative of x by 2 is half. So isn't this f dash x cos x square x by 2 upon 2, right? Fine. So the function and its derivative are there in the box bracket, separated with a plus sign. Okay. So this is f of x f of x. The first part is f of x. The second part is f dash x. So this will be e raised to x, f of x plus c, e raised to x minus cot x by 2 plus c. Okay, fine. Yeah. Next example, integration 1 minus x upon x square e raised to x dx. Okay, so I'll write e raised to x. I'll split it within the box bracket. Within the box bracket, I'll just split it 1 upon x square minus x upon x square. So this is equal to e raised to x 1 upon x square minus 1 upon x. Fine. Now reverse this. Why there is a need to reverse? Why do we have to reverse this? Because the derivative of 1 upon x is minus 1 upon x square. Hence I'm reversing this. Okay. Now this is f of x and the second term is f dash x. Okay. See if f of x is minus 1 upon x. So f dash x is minus, this minus is written over here. 1 upon x derivative is minus 1 upon x square. So this is 1 upon x square. So don't you feel the first term is f of x and the second term is f dash x separated with a plus sign? Yes or no? You can put your answers over chat. Yes or no? Yes or no?
Yes, sir.
So this is f dash x plus f dash f of x plus f dash x and there is e raised to x outside. So we are going to write the answer as e raised to x f of x plus c, and your f of x is minus 1 upon x, minus 1 upon x. Okay, so the answer is minus e raised to x upon x plus c. Minus e raised to x upon x plus c. Okay, let's take one more example of the same category. Integration e raised to x 1 upon x square minus 2 upon x cube dx. Okay, so see, let's take the first term as f of x. The first term is f of x. F dash x is the derivative of this term. So I'm comparing this with 1 upon x formula. So the derivative of 1 upon x is minus 1 upon x square. So the derivative of 1 upon x square will be minus 1 upon x square the whole square into dy dx of x square, because your x is getting replaced with x square, the chain rule part. Okay, fine. minus 1 upon x raised to 4 into 2x, which is equal to minus 2 upon x cube, right? So this can be written as e raised to x 1 upon x square plus minus 2 upon x cube. The first part is f of x, second part is f dash x. Second part is f dash x. So the integration of this will be e raised to x f of x plus c, which is e raised to x into what is f of x? F of x is equal to 1 upon x square. So e raised to x upon x square plus c. Next question, let's understand how to solve the next question. Fine. Integration of e raised to 2x 2x minus 1 upon 4x square dx upon 4x square dx. Okay. Now the main problem in this particular question is we are having e raised to 2x outside. We need e raised to x outside. Okay. So what I'll do is I'll put e raised to 2x. I'll put 2x as t. I'll go ahead with method of substitution. I will go ahead with method of substitution. Put 2x is equal to t. Okay. So d by dx of 2x, d by dx of t. So t 2 is equal to d by dx of dt by dx. 2 is equal to dt by dx. Okay. Look at equation number 1. Dx will be written as dt by 2. Dx will be written as dt by 2. Fine. Okay. So now try and understand what things will happen over here. Okay. Now first of all, in the main question, I replace the 4x square as 2x the whole square. In the main question, I had 4x square. I'm changing it to 2x the whole square. Are you getting the point? Will you make that change? By writing one more step after equation number 1. Okay, so 4x square was given to you. Okay, or else we can just write like this. Just a second. Yeah, this was our question. So this is equal to e raised to 2x 2x minus 1 upon 2x the whole square dx. This is your equation number 1. Okay, so 4x square is written as 2x the whole square. Now from 1, I is equal to e raised to t minus 1 upon t square, t minus 1 upon t square. Okay, yes guys, can you just suggest over chat what has to be done over here? Can you tell me? T minus 1 upon t square, what can you apply? What should be the next step? Can you think over it? Correct, very good. So all are giving the right answers. We'll have to split this into two parts. E raised to t upon t square minus 1 upon t square dt. T upon t square minus 1 upon t square dt. So e raised to t 1 upon t minus 1 upon t square dt. 1 upon t minus 1 upon t square dt. Fine. Further, I'll write this as e raised to t 1 upon t plus minus 1 upon t square dt. Fine. I need a plus sign in between, so the minus sign is shifted over here. Okay. So now, don't you feel the first term is f of t and the second term is f dash t? Yes. The first term is f of t, second term is f dash t. So the integration of e raised to t f of t plus f dash t is nothing but e raised to t f of t plus c. E raised to t f of t plus c. So e raised to t f of t. F of t is 1 upon t plus c. Okay. Now replace the value of t. T is 2x. So e raised to 2x upon 2x plus c. E raised to 2x upon 2x plus c. Next problem. E raised to x 1 minus x upon 1 plus x square the whole square. Okay. I'll split the square. Square is given in the numerator as well as the denominator. The problem is quite tricky. Okay. Just expand the numerator. 1 plus x square minus 2x upon 1 plus x square the whole square. Don't expand the denominator. Just expand the numerator. Okay. What I've done is I've used a minus b the whole square. A square plus b square minus 2ab. A square plus b square minus 2ab. Okay. Now what? Can you guess? Anyone? Now what can be done? Now we'll have to split. Okay. We'll have to split. See, we are not expanding the denominator is because we didn't expand this. See, because 1 plus x square, same thing is there in the numerator, right? So we avoid expanding in the denominator. That is, don't expand the denominator because we can split now. Same term we got. So this is equal to e raised to x 1 plus x square upon 1 plus x square the whole square minus 2x upon 1 plus x square the whole square dx. Fine. So e raised to x 1 upon 1 plus x square plus minus 2x upon 1 plus x square the whole square dx. I need a plus sign in between. So I shifted the minus sign over here and made plus over here. Okay. Now the first part is f of x and the second part is f dash x. So here I'll help you. Let us understand why the second part is f dash x. Okay, after splitting. So f of x is equal to 1 upon x square. I'll compare this with 1 upon x formula. So f dash x is 1 upon x formula is minus 1 upon x square. So what is the answer for this? So the answer of 1 upon 1 plus x square will be minus 1 upon 1 plus x square the whole square. Minus 1 upon 1 plus x square the whole square. Into dy dx of 1 plus x square. Into dy dx of 1 plus x square. Right? So minus 1 upon 1 plus x square the whole square. Dy dx of 1 plus x square is 2x. So minus 2x upon 1 plus x square the whole square. See, here I did a chain rule. X got replaced with 1 plus x square. So the derivative of it. So hence I just proved why the first term is f of x and the second term is f dash x. Okay. Okay. So if the terms are complicated in the paper, show it to your paper corrector. Right. Fine. So the answer for this will be e raised to x f of x plus c e raised to x 1 upon 1 plus x square the whole square plus c. Fine. Okay. Because we are having f of x and f dash x besides each other. Fine. Okay. As rightly pointed by someone, f of x is 1 upon 1 plus x square. So by mistake, I had put a square over here. So it should be 1 upon 1 plus x square. So next, let's take one more example. X e raised to x plus 1 the whole square dx. E raised to x upon 1 plus x plus 1 the whole square dx. E raised to x. See, now this time we'll make the numerator as x plus 1. So I'm writing x plus 1. Okay. So that we can split. But then what should be written outside the round bracket over here? On purpose, we have written x plus 1. What should be written? Yes, correct. Minus 1. You have to write minus 1. So e raised to x. I'll show you the previous slide. Those who are copying, I'll just show you the previous slide. X plus 1 minus 1. So x plus 1 the whole square minus 1 upon x plus 1 the whole square dx. So e raised to x 1 upon x plus 1 plus minus 1 upon x plus 1 the whole square dx. Okay, this minus I've shifted over here. So f of x is 1 upon x plus 1. F dash x will be minus 1 upon x plus 1 the whole square into d by dx of x plus 1. because when we compare 1 upon x plus 1 formula with 1 upon x, okay, I'll compare this with 1 upon x. So x gets replaced with x plus 1, hence the chain rule. So the derivative of this will be finally minus 1 upon x plus 1 the whole square, because this becomes 1. The derivative of x plus 1 becomes 1. So we are having f of x and we are having f dash x. We are having f of x and we are having f dash x. Okay. So the answer will be, I'll write it over here, e raised to x f of x plus c, which is e raised to x 1 upon x plus 1 plus c. 1 upon x plus 1 plus c. Fine. Okay. Let us take one more example. Now, before we proceed with the next example, what we'll do is we'll understand this thing. If log a equal to b, therefore a is equal to e raised to b. If log a equal to b, a is equal to e raised to b, right? So the reason being the base is e over here. So this part is called as logarithmic form and this part is called as exponential form. And e is Euler's identity. Okay. So there is no base, so we are taking the base as e. So if log a is equal to b, a is equal to e raised to b. You have to remember this. Fine. So let's take an example. Integration of tan of log x plus sec square log x dx. Put log x is equal to t. D by dx of log x, d by dx of t. Okay. D by dx of log x is 1 upon x, which is equal to dt by dx. Now there is no 1 upon x in the problem. Do you find 1 upon x anywhere? No. We only find dx. So dx is equal to x into dt. Dx is equal to x into dt. Okay. Fine. Now we have to eliminate this x. We have to eliminate this x. So we'll write dx as, okay. Now log x is equal to t. So you can apply this property. If log x is equal to t, if log x is equal to t, x is equal to e raised to t. Okay. So here also I'll apply e raised to t dt. Fine. So let this be equation number 1. So wherever you are seeing dx, you'll write e raised to t dt. Log x will be written as t. Okay. So this can be written further as from 1 tan t plus sec square t and dx is e raised to t dt. Dx is e raised to t dt. So e raised to t tan t plus sec square t. dt. So this is f of t and this is f dash t, f of t and f dash t. Okay, fine. Okay, so this is equal to e raised to t f of t. The derivative of tan is sec square, right? Okay, so the first term is f of t, the second term is f dash t. Okay, now e raised to t. What is e raised to t in the problem? E raised to t is nothing but x. See, x is e raised to t. Okay, and f of t is tan t plus c. So this is equal to x tan. What is t? T is log x. T is log x. Fine. We replaced e raised to t with x and the t with log x. So two more problems of the similar category. You can practice it on your own. I'm giving you two problems for practice. I is equal to integration of sine log x plus cos log x. You can practice this on your own by taking log x as t. And the second problem is log of log x plus 1 upon log x dx. You can take log x as t in both the problems. Okay, and eventually you'll get the answer. Same thing you need to follow, that is by putting log x is equal to t, method of substitution, and replace x with e raised to t using the exponential form. One more example we'll take of the similar category. That is the last problem of this category. I is equal to log x 1 plus log x the whole square dx. 1 plus log x the whole square dx. Okay, I'll write put.
So here we cannot do solving log x plus one.
Once again, I will run through the entire problem. Log x upon 1 plus log x the whole square. I'm putting log x as t. See, method of substitution. D by dx of log x is 1 upon x. And this is dt by dx. Cross multiply. You'll get dx is equal to x dt. Now there is no x in equation number 1. Look at equation number 1. There is no x. So x is replaced with e raised to t. Why x is e raised to t? Because this is the exponential form of log x is equal to t, right? So dx in the next step will be written as e raised to t dt, and log x will be substituted with t. Log x will be t. So from 1 we get this thing, right? So we shift e raised to t first and write this entire thing within the box bracket. Okay, t upon 1 plus t the whole square, add 1 and subtract 1 and then split. Add 1, subtract 1, then split. And once you split, one term up and one term down gets cancelled. So we are left with 1 upon 1 plus t. Okay, minus sign is shifted with this 1 and we write a plus sign in between. Okay, so this is what you get. f of t is 1 upon 1 plus t. F dash t, derivative of 1 upon 1 plus t. Derivative of 1 upon 1 plus t is minus 1 upon 1 plus t the whole square. We'll compare this with 1 upon t formula into dy dt of 1 plus t. Dy dt of 1 plus t is 1. So 1 into this is this f dash t. So as per the property, we are getting e raised to t f of t. E raised to t f of t. E raised to t is nothing but x, right? E raised to t is nothing but x, see? And f of t. F of t is 1 upon 1 plus t. And replace this t with log x. That's your final answer.